Hello, my name is Aliyah and I did chapter 11, and my question comes from section 11.1, which is a test for goodness of fit. My question reads, a world-renowned pulmonologist wants to know if the amount of people who smoke cigarettes per state has changed since a study conducted in 2013. In 2013, 30.2% of people smoked in Kentucky, 29.9% in West Virginia, 17% of civilians smoked cigarettes in Washington, and 12.2% in Utah. The lung doctor randomly selected 1,000 individuals from each of the 4 states and obtains the frequency distribution available on the next slide. Does evidence suggest that the amount of people who smoke cigarettes in those 4 states is different today than it was in 2013 at a 0.05 level of significance? First, we need to state the null and alternative hypothesis. The null hypothesis, marked as HO, says there's no difference between 2013 and today in smokers. The alternative hypothesis, which is H1, says there's a difference between 2013 and today in smokers. So now we have to determine the expected frequency for the various states. So starting with Kentucky, we are going to multiply the amount of people, so that's 1,000 people times the percent at which the amount of people that smoke, and that's 0 in decimal form, that's 0.302, and that comes out to be 302 for our expected count. Then we have West Virginia. And again, we have to multiply the amount of people times the percent in decimal form, and that's 0.299, which comes out to be 299 people for expected. Washington, the same again. 1,000 people times percent in decimal, 0.17. That comes to be 170 people. And finally, Utah, 1,000 people times decimal form, 0.122, comes out to be 122. Now we're going to find our critical value using inverse chi-square, and to get inverse chi-square you select F5 in your calculator, scroll down to 2 inverse, press enter, scroll down again to 3 inverse chi-square. So now we have to figure out the area in degrees of freedom, and you always put the area to the left, and our level of significance is 0.05, so the area to the left is 0.95. Then our degrees of freedom is found using n-1, so 4 minus 1 comes to be 3. When you put that into your calculator, our critical value comes out to be 7.815, and we have to round to 3 decimal places. Our final step is finding our test value. So first, in order to find our test value, we need to enter the data into list 1 and list 2. So for list 1, and you're going to use the stat list, and in list 1 you're going to put the observed frequencies. So that's 284, 290, 133, and 131. And then in list 2, you're going to put the expected frequencies, which is 302, 299, 170, and 122. Now to find the test value, we're going to use 7 chi to go F. And to get there, you're going to select F6, scroll down to 7 chi to go F, push enter, and then in the observed list, you're going to type in list 1, in the expected list, you're going to type in list 2. And then in the degrees of freedom, you're going to put 3 and push enter. And when you do this, your test value will come to be 10.061. Now, if you put that on your graph, you can see that 10.061 falls into the shaded region, and that means we're going to reject the null hypothesis. So now we have to make a statement with the summary of our results. Since we rejected the null hypothesis, that means that there is enough evidence to support the claim that there's a difference in the amount of people who smoke in the various states from 2013 to today.